Okay, so the last way to calculate the delta H for a reaction is by using bond energies. Okay, bond dissociation energy is the quantity of energy required to break 1 mole of covalent bonds. Okay, so bond breaking is always endothermic. Bond formation is always exothermic. So forming bonds is an exothermic process. Heat is always released when bonds are formed. Heat is always absorbed when bonds are broken. And whether or not an overall reaction is endothermic or exothermic just depends on whether the bond breaking or the bond formation absorbs or releases more energy. So in order to do this process, we need to use a table of bond energy. So again, this would be something that's provided to you, not something you have to memorize. So you notice you're looking at your different bond types right there. The formula for this is a little different than the formula of the heat of formation. The heat of reaction is equal to the sum of the heats of reaction for the bonds broken minus the sum of the bond energies of the bonds formed. So let's take a look at this problem. Okay, these problems are going to be a lot simpler. Okay, so here's my reaction, here's my table of bond energy. So the first thing I need to do is figure out what bonds exist. So here I have H bonded to H. That would be H2. So that's one reactant. And I have F2, so that would be F bonded to F. And what that's giving me is 2 HF bonds. So I get 2 HFs. Okay, so if I want to know the delta H for this reaction, it's the sum of the bonds broken. So one H to H bond is broken, plus one F to F bond is broken, minus 2 times 565, because I formed 2 H to F bonds. So when I do this math, I get negative 544 kilojoules per mole reaction.